Hello, today I'm going to have a look at the trapezium rule and where the trapezium rule comes from. Before we start, we need to go over a little bit of area from GCSE. Here we've got a parallelogram, and I want to know what the formula for the area of the orange parallelogram is. So the first thing to spot is I can change my parallelogram into a rectangle by taking one of the corners and cutting it off and putting it on the other side. I know that the area of a rectangle is length times width. Here I've called the length b and the width h. So the area of this rectangle is b times h. When I move the triangle back, I've not removed any parts of the rectangle. I've just rearranged it to get my parallelogram. So because of that, I know that the area of a parallelogram is the same as the area of the rectangle was. And the area of the rectangle was base times height. The next thing that we're going to need is the area of a trapezium. So here we've got a nice green trapezium. I want to know what the area of it is. So what I'm going to do is I'm going to take it and I'm going to rotate it round. I'm going to slide it and put it next to itself. And now I've got a parallelogram. I know that the area of this parallelogram is base times height. Well, because the bottom of my trapezium was B, the top section of this trapezium is going to be B, and because the top of my trapezium was A, the bottom bit of this trapezium is going to be A, and the height of my trapezium stays the same, so it's still H. Now I know I've got the whole length A plus B. I've got to go along A, and then I've got to go along B, so we've got A plus B. So the area of this parallelogram is going to be area equals my base, or my base in this case is B plus A or A plus B. So we're going to go A plus B, and then we need to times it by the height, which is still just H. But that's the area of two trapeziums, and I only want one trapezium. So the area of my trapezium is going to equal a half A plus B times my height. There's a rhyme you can use to remember it, and that is half the sum of the opposite sides times the distance between them. That's the way to calculate the area of a trapezium. And that's half the sum of the opposite sides times the distance between them. That's the way to calculate the area of a trapezium. And you can do that to the tune of Pop Goes the Weasel. So what that means, if we look back at our trapezium, so here I've got my trapezium, half the sum of the opposite sides, so my side A and my side B are my opposite sides, times the distance between them, so that's my H. So we're doing half the sum of the opposite sides is half the sum, and we've got to remember that sum means add, times the distance between them, times H. That's the way you calculate the area of a trapezium. So there's no excuse for not remembering this now. Why is this useful to us? Well, in use of maths, we're going to use trapeziums to approximate the area under a graph. So here I've got a graph. It's 2 to the power x times sine x. And what I want to know is what this area between 2 and 3 is. Once we've done integration, we'll know that to find the area between 2 and 3, I'm going to use this extended S symbol, and that's going to tell me that the area between the number on the bottom and the number on the top, and then I'm going to write what I want to find the area of, which is 2x sine x, and then we put dx to tell me that x is the important bit. If there's any other letters there, they're going to be constants. It's the x that's the important bit. So let's have a go at putting in some trapeziums. The trapeziums we're going to put in are going to be vertically. The first one looks a bit like a rectangle. So these are going to be our trapeziums. Now, if we have a look at this end trapezium, we can see that it's not like the trapeziums we were finding before, which were on their side. It's now up on its end. So whereas before we had H going from one end to the other. Now we're going to have h going across the bottom. And I've been rather cunning. I've made it so that my h for every trapezium is the same. In this case, because I've got 1, 2, 3, 4, 5 trapeziums, and because I'm going between 2 and 3, I know that the width is going to be 3 take away 2 divided by 5. So I'm doing the distance between the first number, the biggest number, and the smallest number. I'm doing that distance split between 5 trapeziums. And so I'm going to find out that my h is going to be equal to 0.2. And it's going to be 0.2 for every one of my trapeziums. The other bit of information I needed was A and B. And in this case, my opposite sides, my parallel sides, are the ones which are vertical. So let's find the area of my first trapezium. So let's go for area of trapezium 1, and we know that that is going to be a half a plus b times h. Well, we can write in that h is 0.2, and we can put our half in, but now we need to find a and b. So on my trapezium 1, a is this side and b is this side. I need to find the length of this line. Well, the length of this line, because I'm starting at 0 down here, it's going to be whatever this y number is. And I can use y equals 2 to the x sine x. I can use the equation of my red line is 2 to the x sine x to find out what this value here is. I can do 2 to the power 2 sine x is sine 2, so this is 4 sine 2. I'm using radians here. When you come to doing calculus, it really does matter whether you're in degrees or radians, but the trapezium rule will work for either. For my b value, here we're going to do the same thing. I want to know the length of this line, and because I'm going from 0 all the way up to this y number, it's going to be the same as the y value of my graph at 2.2. I'm going to do 2 to the power 2.2 times sine 2.2. And I'm going to do that on my calculator. So I now know that my a value is going to be 3.63719. And my b value is going to be 3.71487. So I've done it to quite a few decimal places because I don't want to lose any accuracy. I can put these into my equation. So I'm going to get 3.64 plus 3.71. Now we know that those are rounded. I'm going to use the exact numbers in my calculator, so I'm not going to make any mistakes. I'm going to find the area of my trapezium. I get the area of my first trapezium to be 0.735 to 3 significant figures. Again, I wouldn't round yet when you're actually doing this, but you're not going to use this method when you're actually doing the trapezium rule. In the same way, I can find the area of my second trapezium, again doing a half base times height, but what you'll notice is the height of the second trapezium is the b value of my first trapezium. So I already know one of my values. I just need to calculate the other value. I'm going to keep doing that for all my 5 trapeziums. Okay, I've skipped to having worked out what the areas of my trapeziums are. Again, I'd recommend doing it to more than 3 significant figures. I've stored all these numbers in my calculator so I can add them up exactly. So now to find the whole area under this graph, all this section here, I need to add up the areas of my 5 trapeziums. And that should give me an estimate. It's not going to be exact, but it's going to give me an estimate of what the area under my graph is. So the total area is going to equal these numbers added together. And when I do that, I get the total 3.02. Now you had it easy there because I cut out me working out the areas of all the trapeziums. But you can imagine from how long it took to do the first trapezium, how much effort it's going to be. What's worse is this isn't even exactly right. Here I've got it done on autograph. And if I zoom in on the top of one of my trapeziums, you can see that there's this area between the graph and the trapezium which hasn't been added in. So this isn't exact. Looking at all my trapeziums, you can see that there's going to be this area in each of them. The graph is curving above the tops of all my trapeziums, which are straight lines. So there's going to be extra area that I don't want. So I know this area is going to be an underestimate. To make that better, to make this area smaller, what I could do is I could use more trapeziums, and then rather than having it splitting at every 0.2, I could have it splitting at every 0.1. And then I'm going to have less of a gap, but I'm still going to have a gap there. The more accurate I want to get this estimate, the more trapeziums I need. So I need a better way of doing this because I need to reduce the amount of work I'm doing. So let's have a look at the general case. Here I've got a general graph. I don't know what it is, but I want to find the area between two numbers, A and B. So we're looking for the area between A and B of some graph. I don't know what it is, so I'm going to call it f of x. And we're looking for this area here. I'm going to call this number x0. And then I'm going to call the next x point x1, the next x point x2, and I'm going to keep doing that until I get to my last x point, which is xn. I'm going to do the same for my y coordinates. So for x0, I'm going to match it with y0. For x1, I'm going to match it with y1. And again, I'm going to keep on doing that until I get to yn. So to find the area for first trapezium, well, we know that the section at the bottom is h, and as we discussed before, to find h, I'm going to do h equals the top number of my x that I'm looking for the area between, take away the bottom one, all over the number of strips which I want, and I'm going to use n for the number of strips. So the area for my first trapezium is going to be a half a plus b times h, but as we discussed before, I can use my y value. So I can say that this is a half, and then my first y value is going to be this one, y0. So I'm going to say y0 plus my next y value, which we've said is y1. I'm going to do that times my h number. So this here is my first trapezium. And then to get the area under the graph, I'm going to add on the area of my next trapezium, which is going to be a half. Now this time, because we're on to our second trapezium, I'm going to use y1 as my a value, and I'm going to use y2 as my b value. So I'm going to do a half y1 plus y2 times h. I'm going to keep on finding areas of trapeziums like this until I get to my last one, which is going to be a half, and it's going to be y, it's going to be the one before yn plus yn times h. Here I've got a lot of typing numbers into my calculator. For each trapezium, I need to type in a half and I need to type in h. To save myself some time, what I can do is I can factorize. I can say every single one of my trapeziums has a half times h in it. So I'm going to start off by writing a half times h, and then I'm going to say, because I'm factorizing it out, what do I need to times a half h by to get the area of my first trapezium? Well, I've already got the half and the h, so the only extra bits I need is for y0 plus y1. So this was my first trapezium. And now, if I move on to the second trapezium, I already have the half I already have the h, so it's only the y1 plus y2 that I need. So I'm going to add those in. When I look at my third trapezium, you should be able to see a pattern by now. I'm going to get y2 plus y3. And that's going to keep on going until I get up to my plus ym minus 1 plus ym. So that's looking good. I've saved myself some effort. I've saved myself having to press a half h every time. But these y numbers tend to be horrible decimals. In the question before, we had our y numbers as being things like 3.63719. I don't want to keep on having to type in these really long, horrible decimals. So it's really effective if I can collect my like terms. So if we have a look at this, here I've got a y1 and a y1. So I can add those together and I can say I've got a half h. Well, I've got nothing to add to my y0, but I've got two y1s, I've got two y2s, I've got two y3s, and that's going to keep on going up until the end where I'm going to have two lots of my second to last y value. I'm only going to have one lot of my yn. Again, I've saved myself quite a lot of effort there, but I can do even better because now I've got to keep on pressing 2. So what I want to do is I want to save myself some time, and I want to say the area is equal to a half h. And now to save myself some time, I'm going to do y0 plus yn. So the ones which I'm only doing one of, my y0 and my yn, plus 2 lots of everything else. So I'm going to factorise out my 2 from all of this middle section. I'm going to get y1 plus y2 plus y3. I'm going to keep on adding those up till I get to my plus ym minus 1. Now, because it can be quite confusing with brackets, what I'm going to do is I'm going to put brackets around my single ones, and I'm going to put brackets around my double ones. But we need to multiply it all together, so I need another set of brackets. And I'm going to draw in curved brackets, but they are normal brackets. When you're doing this on your calculator, you're just going to use round brackets for our curved brackets, just like normal. And this is the trapezium rule, which if you're doing normal maths is in the formula book, but if you're doing use of maths, I'm afraid you're going to have to learn this formula. It's not too bad. It's a half times h times the first and the last y values plus 2 lots of all the rest of the y values. Again, if this goes wrong, it's going to be because you've forgotten some brackets. The common follow-up questions you'll be asked is, if you've got a graph which looks like this, and you're finding an area, is it an overestimate or an underestimate? The best way of doing this is to sketch the graph, have a look, is the curve going below your trapeziums, if you draw a straight line on the graph, or above it? So here I've got one where my trapeziums are going above my graph, and if I draw a graph which looks like this, like we had in the first question, here I've got one where my trapeziums are going below my graph. If you're asked to explain whether it's an underestimate or an overestimate, the wording is very important. So for the first one, this is an overestimate because I'm finding more area than I want. And the reason why is because the tops of the trapeziums are going above the graph. And my second graph is an underestimate. And it's an underestimate because the tops of my trapeziums are going below the graph. The second sort of question that they can ask as a follow-on question is, how could you make your estimate more accurate? Well, we said before, if I put in extra trapeziums, I'm not having as much wasted space. So the best way of improving your estimate with the trapezium rule is to use more strips or more trapeziums. And that's the trapezium rule.